Okay, guys, it's David Lamb. We're going to start the webinar, so I'm going to hand it over to Roger. Your phone should be muted, but if you've got any questions, please don't hesitate to post them under the question button, and we'll answer them as they come up and as we see them. Okay? Here's Roger.
Hi, good morning. As David had said, I'm Roger from Quality Equipment Sales, and what we were going to go through today was the Peerless indirects and advantages of putting an indirect in. I want to go through some of the piping issues, sizing issues, and just make sure that you understand what we have available for indirects. There are, just down key. Yeah. Using the Peerless indirects, they have basically we're going to use the boiler to be able to heat our domestic hot water. And we're circulating the water through a coil or a heat exchanger inside the tank itself. What's nice is we have a lot of capacity to be able to heat domestic hot water. So if you have large domestic hot water use, the indirect is great because we can now use the complete capacity of the boiler as opposed to using a 40,000 or a 50,000 BTU water heater. It allows my boiler to be cold start. I was actually doing a seminar last night, and I have a customer that's using oil. They have an old, inefficient boiler. They're running about 70% combustion efficiency. They have a tankless coil, so the boiler maintains temperature. The customer could probably drop his bill in half by installing an indirect and putting a newer oil boiler in that particular installation, and we could drop his fuel bill in half. They're spending about $2,000 a year in fuel, so basically we could save them $1,000 a year by upgrading their equipment. So the indirects do have a great fuel savings for the consumer. And where the fuel savings come from is we don't have the boiler sitting there maintaining temperature if you have a tankless coil that's installed now. So anyone that has a tankless coil, as long as you have the space to put the indirect, it's a real nice advantage for the customer. One, they're going to have steady flow of domestic hot water and not the fluctuating temperatures that you'd get out of a tankless coil. And they'll get more hot water, and they'll save money while they're doing it. And instead of the boiler sitting there maintaining temperature, we're allowing the boiler to go cold start, which means if there's a low limit control on the boiler, you can turn that low limit all the way down on your boiler control. Now, if you have some of the older, which I'm sure you do, the Honeywell L8124 controls, when you turn that dial down, the bottom temperature is about 100 degrees. And so there's a stop there, so it still maintains 100 degrees on the control itself. What I've done in the past is actually if you take that red knob, pull it towards you, and turn it past the stop and push it back in, you actually can reduce it down below that 90-degree setting. So we can pretty much, without rewiring, take a control that was maintaining some sort of a minimum temperature and kind of turn it off. I know that's not the way the control was designed. I'm just letting you know what I've done on installations to be able to get it so that it doesn't maintain the temperature. When you do an indirect and tie it into a boiler, the boiler is going to cycle several times a day to maintain through your domestic. What you're going to find is the boiler is probably going to be maintaining an average of maybe 110 degrees. It's just when you're away on vacation and you don't want it to maintain at all, or you're not using very much water, it's not going to cycle a whole lot, and it may drop the temperature down on the boiler even a little bit farther. But under normal usage, you're going to find that your boiler is probably about 110 on the average. Producing domestic hot water in an indirect, if you have a tankless coil, definitely is going to be less money than using the tankless coil. I mentioned on here that producing domestic hot water may be less costly than when using a high-efficient boiler than using a separate water heater. And where that comes into play, if you have an old, inefficient boiler that has a large mass, a high-efficiency gas water heater, the actual cost may be a little bit less than where the indirect is. Years ago, I had an application where a customer took an old inefficient boiler against a high efficient gas water heater, and the production of domestic hot water was actually less with the high efficiency boiler, but with the high efficiency water heater rather. So with the newer boilers, higher efficiency with the indirect, we're definitely going to be comparable fuel cost wise between the two. One of the big advantages to the indirects is the lifetime warranty. So when you're residential applications, it's a full lifetime warranty. As long as that homeowner lives in that house, it is a lifetime warranty. Commercially, we do a 5-year warranty, which is still pretty good for a commercial application. So we have 5 years warranty against the tank on leakage. I put a piping diagram in for a standard cast iron boiler where we would actually just pipe it in as another zone to the heating system. I try and get it as the first zone off of your loop so that during the summer months, basically all we're going to be doing is heating as little piping as possible down in the basement, and the first zone off is where the boiler water will go into the indirect, and it doesn't heat a lot of the other pipes down in the basement itself. If you get into a high efficiency boiler, low mass, there are a couple different options for piping. This is one showing the primary, secondary piping for the boiler, which is where you'd normally pipe it. And again, we took it off the system piping, and we took it as the first zone off of the boiler. If you look at our Peerless purifier installation instructions, they also do show it where you actually take it off of your boiler piping. And if you do that, you have to do a little bit different wiring on your circulators. Basically, there's a general circulator on the boiler itself as the primary pump. And on that circulator, you would actually wire it up as a central heating circulator if you took your indirect directly off your boiler piping. So we do show it both ways in the installation instructions. This is the way that seems to be the easiest and eliminates some other issues you could run into. Let's say you have a large boiler and you put a small indirect in and it has a real small circulator. If I take it right off the boiler piping, I don't get the full flow through the boiler. Whereas if I do the piping the way I'm showing in this diagram, I'll have my boiler circulator, the general circulator, circulating water, and I'll guarantee that I have full flow through the boiler, and then I can pull off what I need to go in the indirect from the system piping. So that's why I like to go that way, this particular diagram for the piping of the indirect. I do see them both ways, and you can do them both ways. Just some precautions that I wanted to make sure that you were aware of. This is 2 diagrams showing the piping of the indirect that we're using now. For years, we had used a stainless steel tank, and it was manufactured by heat transfer. It had a copper nickel coil in the bottom of the tank. Last year, we switched to the tank within a tank. It's actually manufactured by Triangle Tube. It's a stainless steel tank. Both tanks have lifetime warranty. The one nice thing about this tank is I ran into an application several weeks ago down towards the shore where they have artesian wells, and they kind of build up a slime like an iron algae. And if you do a coil, it can actually build up on the coil over years and cut down your heat transfer. This, the inside of the tank with the corrugations in the tank, is the actual coil. So it doesn't allow things to build up onto that. So it actually does give you, if you have poor water conditions, it actually does work a little bit better for you from that aspect. The other thing is, commercially, this tank gives you more hot water than just about any other indirect out there manufactured. So if you have an application where you need a lot of hot water, this is the tank that will take care of it for you.
Is this something we would recommend when we're selling a boiler, that we should ask, have you thought about an indirect water heater? Is it one of those, like, super size opportunities we should ask every time?
I think you should. You can basically, when they call in for a boiler size, are you doing domestic hot water? So rather than just looking at the space heating, we can use this high efficient boiler to be able to heat our domestic at the same time. If you combine the two, the total BTUs that I need available is going to be less than having two separate systems installed. So if they are doing an upgrade or they're doing a conversion from oil to gas, the size of the gas line you're going to run is going to be different if you do a boiler and an indirect than if I do two separate appliances.
So that's a great one, is on a gas, where they don't want to increase the pipe coming into the home and take them actually considerable amount of money, because if you have to redo the pipe, then that gets pretty expensive.
Yes, and if you have, like I said, the boiler with the summer-winter hookup in there, it allows me to tie the two together, and it's lifetime warranty on your domestic. And there aren't too many other options where you can get a lifetime warranty on your domestic gas hot water heater. So we have that available here. So it's a good selling feature. Looking at these two piping diagrams for the indirect, they're showing all of your valves, and they numbered the valves. If you start from the very right-hand side where your cold water is coming in, valve number 1, so we'll actually have a valve number 1 will have a shutoff valve coming into your house. We're going to have a check valve, so the hot water is not going to push back out into your cold water line. Then we have a thermal expansion tank. Not required, depends on your area, but the thermal expansion tank will prevent you from building up pressure inside the tank itself. I just did a thermal expansion tank this morning for an application. Happens to be a restaurant. They're going to put a 119-gallon storage tank in. Think of it as an indirect. So a 119-gallon indirect with 90 to 100 psi going to it. They want to store the water at 140 degrees. There's actually it worked out that there was going to be 2.8, I think it was about 2.8 gallons of expansion. So we have that expanded water, and it has to go somewhere. And so that thermal expansion tank allows that expanded water to go into the tank and not build pressure up excessively in the tank itself. After the thermal expansion tank, they're showing a thermal trap loop. I don't usually see that installed most applications, but they're showing that you could put a thermal trap in so you don't get any heat migrating and cooling down in the cold water loop. The next valve that we actually show, they have item 9, unions for quick disconnect. And then they're showing a T before the cold water goes into the tank, and it goes off into number 9, which is a drain valve. If you notice, this tank does not have any valves at the bottom of the tank. And the way you drain one of these tanks is to close your cold water line. One of the valves coming into your cold water line, one of the number 1 valves, and close the valve on the cold water. Open a water tap, hot water tap at the top of the building, and open valve number 9. Put a hose to it. You can let it go to a drain. You can put it to a small little pump to be able to pump the tank out. And if you notice, there's a dip tube that goes all the way down to the bottom of the tank, and basically you can pump the water out of the tank or let it go out through by gravity. So that's how the tank gets drained. Also, this is a stainless steel corrugation, the inside of the tank. When you go to drain the tank, you have to make sure that you have, they'll actually show on this, in the installation instructions, that you might want to put a vacuum breaker on. If you already have a faucet opened up top, it's going to allow air to come through and allow you to drain the tank. It's just if you open that valve number 9 and you didn't open a faucet upstairs, you could actually pull a vacuum and start to collapse the internal portion of the tank. So if you actually had a vacuum breaker on there, which I do not see installers, put vacuum breakers on it. Usually the way you drain it is to open a faucet up top, at the highest faucet, and allow the hot water pressure itself to push all the water through the cold water line through valve 9 and drain the tank. On the outlet side of the tank, we're showing 2 diagrams, one with the recirculation loop on the right-hand side, and on the left side we show it where it's no recirculation loop at all. And we have 3 tappings at the top of the tank, a hot water out, a cold water in, and then we have the 3rd tapping, which could be used for the relief valve, or it could be used to be able to connect in the recirc line. In that 3rd line, it actually has a dip tube that comes down partial distance down to the bottom of the tank, so we can allow that recirc line to be able to drop down near the bottom, but not all the way at the bottom. And if you're not using a recirc line, it's a tapping that you can put your relief valve in. After you come out of the hot water outlet of the tank, you basically will end up having a union they're recommending for isolation, and we have a shutoff valve on the outlet of the tank. And after that, they're just showing your fixtures. They also do show if you want to put a mixing valve on. I recommend to, when you're sizing your tanks, to size it so that you oversize the indirect, so we can actually have them large volume of water per dump load for a large tub. But when you start storing the water at higher temperatures, it will give them the amount of hot water they need, but it's actually less efficient to operate the system. So if you're really looking at saving somebody money, I want you to put in an indirect that's going to be able to handle 80% of the dump load for a Whirlpool tub, and operate the temperature of the boiler as low as you can and store the water as low as you can in your indirect. You're going to increase the life of the indirect. You're going to reduce your fuel costs as much as possible. So I'm really big into this fuel savings, and oversizing the indirect makes your entire system more efficient. Clearances. There's not many clearances that you need. You don't need anything on the sides. You need the front to be able to gain access to the tank. And in the rear is where our piping is connected for our boiler supply and return piping. And we're showing that we want 12 inches in the rear to be able to gain access to that piping. If you were pulling out an existing tank that we have our boiler supply and return near the bottom of the tank. This piping is going to change, one connection near the bottom, one near the top on the side, and then all of our hot water domestic supply and return connections, or hot water in, cold water out, and the cold water in, hot water out, and your recirc line or relief valve connections are all on the top. In our tank that we used to offer, all the connections were on the side. So if you do have a warranty, there's some repiping involved in that. So be sure to take that in consideration when you select your tank if you're ever doing a replacement. One of the nice advantages of doing an indirect is you don't have to add all the BTUs that you need that you would add if you were doing a separate system. So this example, if I have a 2.5 bath, 4-bedroom house, if you were putting in a Peerless purifier, that automatically prioritizes for domestic. We would only need to add 7,000 BTUs. If you had a...
Just put that in context, how many BTUs would you expect on a high efficiency, let's say a Renard system, to provide water for a similar?
If you did a tankless water heater, it's going to be 150 to 180,000 BTUs.
So there's a huge saving
when you're looking at running your gas line for what you'd have to do. No separate venting system, no separate, you don't have to worry about the gas increasing, the gas size to be able to handle the capacity of the boiler and the domestic. What the indirect's going to do is allow you to have storage and be able to get dump loads so that if you have a big whirlpool, you can be able to handle that. And that's one nice advantage of combining the two appliances. The one downside is, if you do lose power, well, even if you did have a tankless, you would still lose the tankless and you'd lose the boiler. But if you had an atmospheric gas where it didn't have any electric going to it, then you could actually have hot water again. So there's isolated cases to where, having the two separate systems, you have to look at the pros and the cons. But usually the boilers are fairly reliable, so combining the systems allows you to, put the most efficient system in and actually have only one fire appliance. So I have a lot of different applications here for the amount of BTUs that you would add, and it's considerably less than putting in a separate system. The boiler is going to basically heat the domestic by circulating through the coil of the tank. Now, typically, most people are going to run the boiler water at 180 degrees, and they usually store their domestic maybe at 120 or 125, maybe even a little bit lower. But you'll usually get about a 25-degree drop through the indirect. So I'll send it over at 180, and the water will come back at 155 degrees. I actually set my indirect at home, so I store it at 120 degrees. So I have my boiler operating at 145. So when it calls for domestic hot water, I end up having the boiler go up to 145. I get my 25-degree drop. Yes, it takes me a little bit longer to recover, but I get the greatest fuel economy by operating my boiler at a lower temperature. So I actually get higher efficiency out of my boiler that way. And as I said before, I want you to make sure that you size the indirect. So if you have a big Whirlpool tub, we have 75% dump load available. If you have a shower that has multiple sprays, how long do they want to take a shower? So if we have it so that they have a shower that's going to give them 10 gallons per minute, and you put a 40-gallon indirect in, just simple math, we have a 4-minute shower. I don't think that's what they had in mind when they put the shower in. So the thing is how long does the customer want to be able to shower, and what do we need to have for dump load and recovery to be able to handle that type of application? So when you get into those larger domestic water use, be careful and make sure that you put down on your quotation, I will give you a 10-minute shower or a 15-minute shower, lay it out. So if there's ever a question, you can provide what you told them you would do and make sure they agree to it. This has all of our dimensions on the indirect so that you can see exactly how it will fit into your space. We do in the installation instructions, they go through the relief valve. And basically for the smaller tanks, we use 100,000 BTU relief valve. And for the larger tanks, the 60, 80, the 120-gallon tank, we actually use a relief valve that is 200,000 BTU relief valve. The reason I mention this is I tried finding a relief valve for a storage tank the other day, and a lot of the supply houses don't have the relief valves in stock with 200,000 BTUs. We provide you the relief valve that you need with the indirect, and you can always come back to Pierce Phelps and get a replacement relief valve if you need it. It's just, I was just amazed when I actually went to find a 3/4-inch relief valve, 199,000 BTUs. I actually stock it, but when I actually checked to a lot of the plumbing and heating wholesalers, it was not available. They didn't actually keep one of those on the shelf. So just a note on the size of the relief valve that you need. It's different depending on the size of the tank that you use. The maximum boiler water is 210 degrees. If you're doing a commercial application, the highest water temperature we can send out of the indirect is 194. And if you're using it residentially, they're recommending to have it at 140 degrees. And the maximum working pressure on the boiler is 45 PSI on the boiler side, which most of your boiler applications are going to be 30 PSI that you're working with on that, 30 PSI relief valve. Also, when you fill the system, kind of think of it this way. This is a tank within a tank. If I go back to the diagram that actually shows you the tank within the tank, the outside of the corrugations that you see on the heat exchanger itself is where boiler water is, on the outside of the tank. Think of this as as setting an electric water heater in operation. You would fill the tank with water before you actually turned on the electricity. The same thing here. You wouldn't fill the boiler side and then fill the inside of the tank with water. If you had high boiler pressure, you could actually crush the tank itself. So normal operating procedure is you would actually fill the domestic onto the inside, then fill your boiler water so that you don't collapse the tank. So the tank actually moves on the inside and it flexes. So although it's very rigid, there's no anode rods, you fill the water side of it first, and then you can fill the boiler side. As far as recovery, this is one of the real big advantages, the recovery that you get. And there's a whole lot of different parameters that you could look at. But we give you a couple different examples. If you have 50-degree water coming in and you need 115-degree out, and you have 180-degree boiler water, we actually give you a couple different figures. If you're going to do a PT40, that's a 40-gallon partner, basically we would need 106,000 BTU gross output. So you're looking for, actually almost a Purifier 110 would almost do that. You'd basically be able to give them 61 gallons in a 10-minute period. So if I had a 50-gallon tub, boy, I'm more than covered with that 40-gallon. I could give them 61 gallons of hot water in 10 minutes. I could give them first hour rating 224 gallons. Now that's figuring your storage in your tank plus your recovery that I could get in that first hour. So I could get them 224 first hour, and then the second hour, if we wanted to get continuous flow, we could get 195 gallons per minute continuous. Divide that by 60 minutes, you're over 3 gallons per minute. So pretty much when you're doing this indirect, as long as you don't have over 3 gallons per minute, and I have 106,000 BTU gross output available, I could take a 3-gallon per minute shower forever and not run out of hot water. Then we give you what the circulator flow rate is. At that parameter, we need 11 gallons per minute to be able to pump boiler water through the indirect and back to the boiler itself. Same figures down below, except we raised the boiler water to 200 degrees. And now we took that 195 continuous, and now we can get 242 gallons continuous. So by raising the boiler water. We're going to lose some efficiency. We also need to increase the pump to 13 gallons per minute. Just giving you some parameters so you can kind of see what you need for dump load. This goes through all of our sizes too. Look, you have a 30, a 40, 50 gallon, so we have a lot of different sizes, a 60, an 80, and 120 gallon. So a lot of sizes there. When you look at that 120 gallon, I can give them continuous flow over 900 gallons an hour. So that's a lot of hot water that I could get at 115 degrees. If we took the parameters and changed it around that we wanted 140 degree, that 900 that I was getting on that 120-gallon partner drops to 560. But we're raising the temperature another 25 degrees. So again, it gives me all my circulator flow rates, and it gives me my 10-minute draw that I could get. So if I have a quick dump load for 10 minutes, here's what I could get out of each tank. And then I could get my first hour, and then after I used all my dump load that I had available, I can get what I can get continuous, hour after hour. Circulator sizing, I tried making it easy for you. So if you use this, because there's a lot of different flow rates that you could use. So if I'm going to put a 50-gallon indirect in, our Grundfos UPS 2699 with 1¼ piping would be able to give me the flow rate that I need to get the recovery that I want out of that particular tank. The 50 and the 60 is using a 2699. The most popular tank is the PT40, and that would be a Grundfos UPS 1558, and that would only require 1-inch piping going over to the tank. And then when you get into the 80 and the 120-gallon, the 120-gallon tank has 2-inch piping to the tank. And we would actually use a Grundfos UPS 43100. That does not come with an internal check valve, and Webstone makes a 2-inch check valve, very inexpensive, that can go right in line and right in between your isolation flanges. So that is what I would use for circulator sizing. Instead of looking at all the charts, use this one sheet. That's how I would base the sizing of my circulator. And I was figuring that you only had 50 feet of piping in between the boiler and the indirect. The indirect's all the way at the other end of the basement. You know, we may have to change the circulator size, but I don't usually find it that way. It's usually pretty much located right near the boiler. thermal expansion tank, I had showed you that right at the beginning, and it's usually put in the cold water line, and having the thermal expansion tank in the cold water, we allow that hot water to expand into the expansion tank. And then after a period of time, as the temperature drops, the water in the tank comes out of the thermal expansion tank and works its way back into the boiler. If you take the thermal expansion tank and put it on the hot water outlet, we'll have hot water, and then when we start to draw, the water may have dropped in temperature in that thermal expansion tank, so now we get a slug of cold water going out. So that's why you usually put it into the return. Plus, it's going to be cooler water. It helps with the life of the tank. And this is a sizing chart that Amtrol came out with. So if you're going to store your water less than 150 degrees, which is most of your applications, if you have an 80-gallon indirect and your incoming water pressure is going to be 80 pounds, you would use an Amtrol ST12. If you have 60 pounds, it drops it down into a smaller size tank. So it basically allows you to just quickly see what size thermal expansion tank. There's no problem with going with one too big, it's just allows the pressure not to build up at all, really, if you put a larger tank in. You can actually put indirects in multiple applications. Nursing homes, hospitals, big apartment houses. We can actually put them in, and this is showing reverse return piping. So the first one that is fed with the cold water in is the last one that gets the hot water out. So we get nice equal flow of water, and you can pipe the boiler piping the same way. So if you have an apartment house where we need to put multiple indirects, reverse return is how I recommend you pipe them. You can use a single circulator, or we could use a circulator on each tank if you want to set it up that way.
So there's clear opportunity in the commercial market for this product as well.
The reason there's a big advantage in the commercial, anytime you have a water heater that goes over 199,000 BTUs, the water heater needs to be ASME stamped if it's a storage type water heater. These, we can actually transfer a lot of BTUs, and the way the state looks at it, as long as you have your boiler water 240 degrees, no more than 240, and your domestic is no more than 210 degrees, you cannot transfer more than 199,000 BTUs. That's the way the state looks at it. And the thing is these indirects, even though I'm showing you the recovery, and I can show you we can transfer more than that, at 240 degree boiler water and 210 degrees stored domestic, I cannot transfer 199,000 BTUs. So these tanks don't need to be ASME. So I can put as many of those in, and it really cuts down the cost. I actually was on a job yesterday, commercial application, where we needed a storage tank, a 119-gallon storage tank. Since the BTU input to the storage tank with the water heaters they were using was over 199,000, my storage tank had to be ASME approved. And so did the thermal expansion tank. So this is a real good application commercially because you can actually put multiple tanks. I actually have a job now where they have massive, large tanks. We're going to pull them out and put indirects in. It is the least expensive way to go when you're looking at that type of application where I need to have storage, because they don't have to go ASME. I can put a bank of them in, and I already have the boilers. So there are some nice applications commercial. So don't forget about those. Residential indirects, lifetime warranty. If you're trying to save your customer money and fuel, I want to spend a little bit more money on the indirect and operate the boiler at a little bit lower temperature. That'll give him the best fuel economy in the system. Consider installing the thermal expansion tank, especially if you have real high pressure. Make sure that you don't forget to add that in. When you're piping your indirect, make it the first zone off of the system piping so that we don't have to go past the piping for 3 other zones first and then do the indirect, because all summer long I'll be heating piping up that I don't need to. Make sure that you put the proper size circulator and run the piping over the size that we're recommending. And we do not have to be ASME, as I had just explained, when you're looking at it for the Anthony rating on the tanks themselves. And if you ever have questions, applications, make sure you give me a call. Come out and take a look at it and see what we could actually use to help you size.
So I have a couple of observations. My sense is this is a very undersold product, that there's a lot of upside opportunity in terms of making our dealers aware and sort of just adding it onto any boiler sale.
Yes.
We haven't done a great job in marketing this and making our dealers aware that we have this capability. So it's up to us, because I think that any boiler sale we make, we should ask about what the hot water opportunity is. Because often the hot water is ignored as an opportunity. It's a 10, 20-year-old inefficient system sitting in the corner. And this will help our dealers collect that opportunity as well.
And this can be sold all year long. If they're just not using it during the heating season.
Right.
So we can use it all year long.
The other observation is that there seems to be a tremendous opportunity on the commercial side. So if we've got commercial, we've got a lot of dealers who have a foot in both camps, both residential and commercial. Then we should make sure that they understand that this also can play out in the commercial space as well. And then my third observation is I've done a few of these webinars with Roger, and my sense is that this is not the first time, but this is the most enthusiastic I've seen Roger about a product. So I think that there's a lot of opportunity just based on Roger's passion. And maybe the next step is we can look at identifying some of your dealers that we can roll this out to. So my request is let's think about a few dealers that we can actually introduce this to and see if we can get them on board as they sell their boilers. Let's see if you've got any questions.
One thing I forgot to mention is I run into commercial applications where commercial water heaters just do not last. We have actually done dedicated systems, indirects and boilers, and now we don't have the heat on the bottom of the tank all the time to get all the minerals to build up, all that heat on that bottom tube sheet, and eventually they get a leak and they have a problem with it. Using the indirects, we don't have that same stress on the tank itself. So I've actually taken apartment houses where they actually put in 2 boilers, 2 indirects. Now we have redundancy and can take care of their domestic hot water issues without having failures on a regular basis.
Okay, no questions. I'm going to wrap this up. Thanks very much. Really appreciate everyone getting on the call. And it's recorded, so if you want to share it with anyone, it's available to share, and I'll send the slide deck out. Thanks very much, guys.